Good evening, children. Welcome to Akshara IIT Foundation. This is Srinivas, your maths faculty. Let us go to the today's class. Right. Now, today we are going to discuss about the synthetic division with the quadratic expression, okay, or quadratic polynomial, whatever. Here, see one of the example. Let us see this. This is the biquadratic polynomial is divided by a quadratic polynomial. We need to find the quotient and remainder as well. Okay, na? Yeah. Now, I am taking the coefficients of a biquadratic polynomials. So, x power 4 coefficient is 1 and x cube coefficient is minus 11, x square coefficient is 44 and x coefficient is minus 76 and last constant term is 48. Okay. While this biquadratic polynomial is divided by quadratic polynomial, let us identify the quadratic polynomial. Here x term and constant terms we are taking as a divisors. Okay, na? That means here minus 7 will be there. I should take 7 and 12 minus 12 I have to take. So whenever this one we are writing as x square minus of 7x plus minus 12, minus of minus 12 we should write, okay. Yeah, like this we have to write. Okay. Now the first condition here, these two places are zeros. That means while you are adding with 1, we are taking the first position 0 and we are adding right. So this is the position for 7, we are keeping zeros, and this is the position for 12. Okay. Now here last position is 0. That means while you are dividing with 7, first and last positions are zeros. With minus 12, first two positions are zeros. Okay. Now add 1 plus 0 is 1. Now first I am going to multiply with 7. 7 ones are 7. I have written here. Minus 11 plus 7 is minus 4. Okay. Now again 7 into minus 4 is minus 28. Here what to write? We have to write that multiply with minus 12. That means first one. Minus 12 into 1 is minus 12. Now check minus 28, minus 12 both are negative terms. While you are adding both of them you will get minus 40. Plus 44 minus 40 gives 4. Okay, now with 7 I have multiplied these two. Now I have to multiply with 4. 7 4s 28. And with 12, 12 with minus 4. That means I have only multiplied one first term. So second term I need to multiply. Minus 12 into minus 4 is plus 48. Okay. Now here two positive terms, one negative term. Let us add the positive terms, both of them. So 20 plus 40, 60 and this 8 plus 8, 16, 76. Plus 76 minus 76 becomes 0. Okay. Now 7 0 0 here. It is satisfies. 7 into 0 is 0. Next minus 12 into third term. Minus 12 into 4 is minus 48. So plus 48 minus 48 becomes 0. Okay, na? Right. Now these two are reminders. These two are reminders and this is the quotient. That means constant term, x square term. We know already if biquadratic polynomial is divided by quadratic polynomial, will give the quotient will be quadratic. Then only x square into x square becomes x power 4. Okay, na? Right. Now this one 4 plus minus 4x and this is x square. So therefore the quotient is x square minus 4x plus 4 and the remainder is 0. Okay, na? So with the biquadratic polynomial I have taken all its coefficients. With quadratic polynomial I have written minus b I have taken minus b and minus c I have taken constants. Okay, na? So here 7 and minus 12 I continue the process, I will get that last two terms as a reminder and first three terms are coefficients. Okay, na? Quotients, not coefficient, quotients. So this is how we are doing the synthetic division by quadratic polynomial with, quadratic polynomial divides by quadratic polynomial. Okay, na? Yeah, let us go to the next question. The relation between the roots and coefficients of a polynomial. The relation between the roots and coefficients of a polynomial. Here we need to check the polynomials which are having the degree 2, degree 3, degree 4. That means different polynomials having different type of roots, right? According to its degree, we can identify the number of roots. For example, degree 4 polynomial, how many roots it will give? 4 roots. Degree 5 polynomial gives 5 roots. Nth degree polynomial, n roots will be given or n solutions will be given. Clear? Now, for example, if a polynomial is in the form of a0 x power n plus a1 x power n minus 1 plus and so on plus n, an. Okay, no? So, if a polynomial whose nth degree, that means whose degree n, we are having the general form for this a1, a0, a1, a2 and so on, an are the coefficients of x power n, and here a0 does not equal to 0. We know the condition already. A0 does not equal to 0. If it is equal to 0, it should not be a nth degree polynomial. Okay, now? Yeah. So, if it is given like this, sum of roots will be given. Sum of, we are representing with the symbol sigma, sum of roots alpha 1. That means a1, a2, a3 and so on, an are the coefficients. If alpha 1, alpha 2, alpha 3, alpha 4 like that, if we are taking that, alpha 1, alpha 2 are roots of a quadratic polynomial. Alpha 1, alpha 2, alpha 3 are roots of cubic polynomial because degree 3. Alpha 1, 2, 3, 4. 4 roots, degree 4 like that. So, sigma alpha 1 equals to minus b by a or minus a0 by or minus a1 by a0. Minus a1 means what? Second term by highest term coefficient, x power n coefficient. Okay, na? This is called sum of roots. Next, sum of the product of roots. Sum of the product of roots. Sum of the product of roots equals to sigma alpha 1 alpha 2. That equals to next one a0. a1 after what will be a0? First one I have taken minus a1 now, here plus a2 by a0. Next one minus a3 by a0. Next a4 by a0. Like this will come. Okay, na? So to understand this, let us take one of the quadratic polynomial and one of the cubic polynomial. I will show you that how sum of the roots, product of the roots, sum of the product of the roots we are taking. Okay, na? Yeah, let us see this. Yeah, I am going to write here. Yeah, this one only. Alpha, beta, gamma are roots of the polynomial. What is the polynomial here? Ax cube plus bx square plus cx plus d. Nothing but a cubic polynomial because it is having 3 roots alpha, beta, gamma. What I did? Sum of roots alpha plus beta plus gamma equals to minus b by a. Sum of roots equals to minus b by a. That means second term x square coefficient by highest term a minus b by a. Sum of the product of, this is called sum of the product of roots. Sum of the product. Sum of the product means alpha, beta, gamma. If you take 3 roots like this, alpha into beta, alpha into gamma, beta into gamma. Alpha beta plus beta gamma plus gamma alpha. This is C by A, sum of the product of roots. Only product of roots. Only product of roots is D by A. Sorry, minus D by A. Here coefficients minus B by A, C by A, minus D by A. These are the formulas we are using for that. Okay, na? Now in case we have 4 roots, nothing but by quadratic equation we have taken sum of roots as the sum of all roots, alpha plus beta plus gamma plus delta. All roots we are taking minus b by a, sum of the product of roots. Here 4 terms are there now, alpha into beta, alpha into gamma, alpha into delta. With alpha I have multiplied 3 of them. Next, alpha completed. Now beta into gamma, beta into delta. That also completed. Next, gamma into delta. So 1, 2, 3, 4, 5, 6 terms will come. So minus b by a already completed. Next, c by a. Sum of the product of roots. Now, again sum of the product of roots. Here we have taken with 2 terms. This is with 2 terms. So among 4 terms we can take 3 terms also now. So that means alpha, beta, gamma first 3 terms. Next alpha, beta, delta first term, that means I am leaving that gamma. Again beta, gamma, delta, alpha, beta and delta. Okay na? So like this. Yeah, like this we are having 4 terms by using 3 terms here. That is minus d by a. And last one, product of roots, alpha into beta into gamma into delta, d after e by a. Okay na? So this is the relation between coefficients and roots. Coefficients and roots. Okay. Now let us see this. The coefficients of a polynomial are rational. Coefficients of a polynomial are rational, then you will have that conjugate surds. Conjugate surds. Okay? That means if f of x equals to 0 is an equation with rational coefficients, so irrational roots occurs in pair as conjugate surds. What will appear? Irrational roots will be appear. Now here see, coefficients of a rational number, irrational number such that one of the number is, okay. Now here 2 conditions you should remember. The coefficients of a polynomial are rational, then the roots alpha a plus root b, where a comma b are rational, and conjugate surd. For a plus root b, conjugate surd will be a minus root b. That means 2 surds. If you take any one of the surd, we can use automatically its conjugate. That means 2 plus root 3, one of the surd you know, one of the surd is the root of the given polynomial. Then we can take 2 minus root 3 also, it's conjugate surd. When it is possible, the coefficients are rational numbers. Okay na? Next, if the coefficients of a polynomial of an equation of rational numbers are root a, root b, 2 irrational numbers are there. Okay na? What is this? This is about the coefficients. Irrational numbers are there such that one of the number will be root a plus root b, root a minus root b, minus root a plus root b, minus root a minus root b are the roots of the equation of all the 4 numbers. Okay na? This is also you should remember. Next, solve this equation. X power 4 minus 9x cube plus 2x square minus 29x plus 6 equals 0. One root being 2 minus root 3. One root being 2 minus root 3. What is the other root? 2 plus root 3, right? Other root definitely will be 2 plus root 3. Here see, all are rational numbers. Their coefficients are rational numbers. So one of the irrational side we got, that means 2 minus root 3. Then automatically its conjugate pair is 2 plus root 3. Okay na? Right. So one of the root is given. One of the root equals to 2 minus root 3. So its conjugate root. Its conjugate root is 2 plus root 3. Okay na? Yeah. So let us solve this equation. Okay na? Right. So 2 minus root 3, 2 plus root 3. I am taking the sum of roots. What is sum of roots formula? Alpha plus beta plus gamma plus delta equals to minus b by a. Okay na? These two are taking these two roots. 2 plus root 3, 2 minus root 3. 2 plus root 3 plus 2 minus root 3 plus alpha plus beta. That equals to minus b by a. So minus b value is what? Minus 9. So becomes plus 9. A value is 1. So nothing but this is 9. Okay na? Now see here, plus root 3 minus root 3 cancel, 2 plus 2 4. Then sum of roots alpha plus beta equals to 9 minus 4, that is equals to 5. 9 minus 4, that equals to 5. Okay, na? Yeah. Now let us take that product of roots. Alpha into beta into gamma into delta. Product of roots, what is that? Minus d by a, right? Minus b by a, c by a, minus d by a, e by a. So this is biquadratic now. So biquadratic means what will come here? See here, 4 roots means e by a will come. Let us take that. So e value is 6. E value is 6. A value is 1. But alpha plus beta, we know 2 of the roots. 2 plus root 3 and 2 minus root 3. 2 plus root 3 into 2 minus root 3, it is in the form of a plus b into a minus b. A square minus b square, answer will be 1. See this one, 2 plus root 3 into 2 minus root 3 in the form of a plus b into a minus b. So a square minus b square. 4 minus 3, 1. So in the place of delta, gamma and delta, we can write 1. Then still what is remaining? Alpha beta. Alpha beta is 6. Okay, no? So from this we need to identify alpha and beta roots. Okay, let us check. Alpha plus beta value we know 5. Alpha into beta value is 6. Now I am applying alpha minus beta. I am using here space. I am writing the formula alpha minus beta whole square is equals to alpha plus beta whole square minus 4 alpha beta. Can I write like this? Because a plus b whole square, a square plus b square plus 2ab. 2ab minus 4ab becomes minus 2ab. It is nothing but the formula for alpha minus beta. That means a minus b whole square formula. Let us substitute here. Alpha plus beta value is 5 we got. 5 square value 25. And alpha into beta value we got 6 into 4, 24. So 25 minus 24 is 1. Alpha minus beta is equals to 1. Sorry, alpha minus beta whole square equals to 1. Alpha minus beta equals to plus or minus 1 or 1. Now alpha plus beta value 5. Add both of them. Add both of them, you will get 1 plus 5, 6. Alpha plus alpha, 2 alpha. From this I can learn alpha is equals to 3. Because 6 by 2 equals to 3. Alpha value 3. Alpha value 3, then what is beta value? Beta value 2. Okay, na? Like that we can identify the remaining 2 roots. Solutions. Okay. Now solve this equation. Same like this. Two of its roots are given, remaining we need to find. Same process. You try this one, okay na? Yeah, this is the same problem. Now see this polynomial with degree 5. We are having the roots minus root 3, 1 minus 2i. Now this one I am writing here. I am using this space here. So that is x power 5 minus x power 4 plus 8x square minus 9x minus 15 equals to 0. Two of its roots are given, minus root 3 and 1 minus 2i. What is its conjugate? Conjugate will be 1 plus 2i. 1 minus 2i conjugate is 1 plus 2i. Minus root 3 conjugate is plus root 3. Minus root 3 conjugate is plus root 3. That means I know 4 of the roots. Here degree 5 polynomial. Degree 5 polynomial means it must have 5 roots. So I know 4 of the roots by using the condition. If you have one of the conjugate pairs, means one of the conjugate pairs, we can write the another conjugate one also. 1 minus 2i conjugate one is 1 plus 2i. Same minus root 3 conjugate is plus root 3. Now sum of roots. These 4 roots plus one more root. Fifth root we not know. We should know. No? Let the fifth root is 5. Let the fifth root is 5. Okay. Now first root root 3 plus minus root 3 plus 1 minus 2i plus 1 plus 2i plus alpha. Fifth root is, let us take alpha. Okay, no? Is equals to, what is the sum of roots formula? Minus b by a. Okay, na? Minus b by a. Second power what? Minus 1. So minus of minus 1 by a value also 1. Minus 1 of minus 1 means plus 1. 1 by 1 value is 1. Here we got the answer 1. So let us check the LHS parts. Plus root 3 minus root 3 cancel. Minus 2a plus 2a cancel. Here 1 plus 1 2. So 2 plus alpha is equals to 1. Alpha is equals to 1 minus 2. Plus 2 transpose that side. So what is alpha value? Minus 1. This is the fifth root. By using the condition, I can use the conjugate pairs, conjugate terms like this. Okay, na? Conjugate sorts 1 minus 2a ki 1 plus 2a. Same way minus root 3 plus root 3. Now sum of roots. Sum of roots means minus a1 by a0. Minus a1 means first thing. Second coefficient, no? a0 x power n. Sorry, not this one. Yeah, here also same answer. a0 x power n plus a1 x power n minus 1 like that. Second coefficient minus a0. This is the answer. Okay, let us go. Now we need to discuss about the polynomial conditions, like when the roots are in the form of arithmetic progression, geometrical progression and harmonic progression. Three conditions, let us identify them. So for that I am using the cubic polynomial general form. What is the cubic polynomial general form? Ax cube plus bx square plus cx plus d. This is the cubic polynomial, right? Yeah. Now the cubic polynomial roots are in AP. Roots are in AP. AP means arithmetical progression. Arithmetic progression. I told you already, arithmetic progression is nothing but a list of numbers in which each term is obtained by adding a fixed digit to its preceding number except the first number. Okay, na? So clearly, arithmetic progression is nothing but a list of numbers. In that list, every term is formed by adding a fixed number. That fixed number can be positive or negative. If you add some fixed number to a term, third term will come. Means for first term will be there 1. I am adding fixed number 5. 1 plus 5 how much? 1 plus 5, 6. Next, 6 plus 5. Yeah, 1. 1 plus 5, 6. 6 plus 5, 11. Next, 17 like that. That means I am adding a fixed number is 5. So that's why each and every term is forming. That is called arithmetic progression, fixed number. Okay, what not? Let us see. Now, same like that, I am taking 3 roots. By a quadratic cubic polynomial means containing definitely 3 roots. Let us take the 3 roots are alpha minus k, alpha, alpha plus k. K is the constant term, fixed number I am adding here. Okay, now. Now, as it is, use sum of roots alpha minus k plus alpha plus k. Sum of roots equals to minus b by a. Okay, na? Second highest power by first highest power. Minus k plus k cancel. Alpha plus alpha 3 alpha is equals to minus b by a. Alpha is equals to minus b by 3a. Why I am taking the roots like this? Because clearly given that roots are in arithmetic progression. That means arithmetic progression is nothing but they are formed by adding a fixed number. So that is the fixed number is I am taking k. Here minus k, if you add k, minus k plus k alpha will be. For this alpha again add k, alpha plus k will form. Okay, na? So these are the roots which are in arithmetic progression. Now I found alpha value minus b by 3a. This minus b by 3a, let us substitute in equation 1. This is equals to 0. Let us substitute in equation 1. Okay. Now let us see. So that is a into x cube. In the place of x, we need to write minus b by 2a whole cube plus b into x square. So minus b by 3a whole square plus c into x, c into minus b by 3a plus d equals 0. I just substitute like this. Now let us simplify this. Minus b whole cube. Whenever you have odd power, minus term will be minus remains same like that. If it is even power, minus term also become plus term. Okay. So for this, I can write here a into minus b cube by this one 3a, right? 3a whole cube. That means 27a cube. 27a cube. Now here minus term become plus term, b square into b cube by 9a square plus into minus, this will be minus bc by 3a plus d equals 0. For all of them, I am going to multiply with 27a square, because here 1 square a cube cancel in a square times. So 27a square I am going to multiply. Still what is remaining? Minus b cube, because here numerator denominator cancel. Plus here how many times 9? 3 times. 3 b cube minus here how many times here? 27a square in 3. 9 times, 9a times, 9a into bc, 9a bc, plus 27 into d square, 27 a square into d equals 0. This is the condition. But here there are two like terms, minus b cube plus 3b cube. 3 minus 1, 2. So for this you have to condition 2b cube minus 9abc plus 27a square d equals to 0. This is the condition of cubic polynomial when the roots are in arithmetic progression. Okay now? Yeah. Let us go to the next concept. If the roots of a cubic polynomial are in geometrical progression, GP. Geometrical progression means that is the list of numbers which is formed by multiplying a fixed number. Arithmetic progression is formed by addition of a fixed number. Here multiplication of a fixed number. Let us see that the roots I am taking are in GP. Roots in GP. Let the roots are. I am taking the roots as alpha by k. If I multiply a fixed number k with first term, alpha will form. Alpha into k, alpha k. Three roots came. Now I am using product of roots. According to my consumption or situation, I can use any one of the condition, like sum of roots, sum of the product of roots, or product of roots. I feel product of roots is better to me because there is a cancellation in the 3 roots. That's why I am using the product of roots and the condition also. So product of roots equals to alpha by k into alpha k. Product of roots, sum of roots minus b by a, sum of the product of roots minus c by a, product of roots minus d by a. Okay na? Cancellation, alpha into alpha cube. Alpha cube value minus d by a. Alpha is equals to minus d by a whole to the power of 1 by 3. Now alpha value again substitute in equation 1. This is taken as equation 1. Substitute in equation 1. Okay. So let us write a into, in the place of x we can write minus d by a power 1 by 3 whole cube. This is only the place of x. I am using here whole cube. Plus b into x value minus d by a power 1 by 3 whole square plus c into x value minus d by a whole to the power of 1 by 3 plus d equals to 0. Let us simplify this.